Okay, we are talking today about 5.6. It's going to be a two-part setup. So this will be just the first part of 5.6, and then we'll do the second part tomorrow. So on this 5.6, this is trend lines and correlation is what it's titled. So trend lines and correlation. Trend lines and correlation. Now, when we talk about trend lines and correlation, there's two words that they end up using, and the definitions, I'm not going to make you memorize the definition, but you have a trend line, okay, and then you also have a line of best fit. So those are some words that you're going to see. The definition you can read. I'm not going to make you write it down. It's on page 248. A trend line is a line that estimates the relationship of data, and then a line of best fit is a trend line that best illustrates the relationship of data. So we are going to look at, what this does is we are going to look at data, okay, and the data is just points and that we would plot based off of different data that you might take. It could be test scores, it could be shoe sizes, it could be the height of basketball teams, it could be the number of chirps that crickets make based off of how cold the temperature is. It could be the inches of snow that fall in December, January, February, March, like in Montana. Any variety of data things that you would plot, and you can plot that data, whatever the data is, and make points. And when you do that, okay, if your points look, something like this, whatever the data is that you're plotting, and you look at that, you would say, okay, if I were to envision, could I draw a line that looks like it kind of goes through those points and represents what that looks like? And you could plot some data and say, yeah, that actually looks like I could draw a line that looks very similar to all those points. Now, not all the points are going to be on the line, but that would be a line that would represent that data. That's what we would call like a line of best fit that fits those points. Now, if you were to draw a line through the 2 points, it wouldn't be the line of best fit if you say, oh, I'm going to pick this point and this point, and you go like this and draw this line. That line does go through 2 points of the data, but it does not represent, it's not the line of best fit, because it's like, well, it's going down in this direction, but if you look at all the other points, they're going up in this direction. So the line of best fit would actually be, in this case, it looks to be the red line I drew through those two blue points. That would be the line of best fit. This would not be the line of best fit because it doesn't represent the data. It's not a trend line, okay? Now, not all data sets that we plot have a correlation of lines. Like if you plotted this and this and this and this, it's like, well, is there really a line that represents that data? It's like, well, a line through there, well, that doesn't really represent these two, but a line through here doesn't represent these two. A line through here doesn't represent those two. So you could draw, a line through these two, but it doesn't represent those two. So you could keep doing that. There's really no line that represents that data. And that type of data would just be scattered random points with no real relationship to it, at least not a linear relationship to it. Versus something over here, this looks like there's some sort of linear relationship to it. So we're going to be working on the lines of best fit. You can have in data, you could have points that look actually something, like this, let's say. And those ones, they may not make a line. We're not going to work with these right now, but they would actually make some sort of curve, and that could be a quadratic is what we call those. And so there could be a curve to different types of data that we have, but we're not going to work with those today. We're going to be focusing on the concept of lines of best fit, but you can have data that would fit some sort of curved model like that. Or sometimes, like I said, data has no correlation, there's no relationship, it's just random points put in there. So with that, then, going to look at some, let me erase this. We're going to look at some data. So again, if I'm writing, you're writing. Make that a tally of 53. When you look at data, so kind of like I discussed, if we look at this data, we say, yeah, that looks like it's got this relationship where a line kind of fits that data. These ones over here, very scattered. It doesn't look like any specific line fits the data very well. So we can look at data, and it's what we call a correlation relationship. So if I have data and it looks something like this, a bunch of points like this, okay, graphed. This is what we would call a strong, okay, positive correlation. So this is a strong positive correlation. Now, it's strong because all the points form, essentially they're going to form a line through here. So it's called a strong positive correlation. And so it's strong based off the fact that all the points are going to make some sort of like line if you think about drawing a line through those. Okay, and we say, well, I'm going to, you know, if I drew a line through there, a line would represent very well all those points. Not all the points are on the line, but a line represents closely what all those points are. So that's why it's strong. Okay. The positive aspect comes from the fact that these points, this line, would be going in a positive direction for the slope. The slope would be positive, as it would be going ascending into the first quadrant like that. So that would be a strong positive correlation. Okay, a strong negative correlation, so that's strong positive. A strong negative correlation would look something like this. Same tight-knit group of points, but they would be going down in a negative direction. So something like that. And if you were to draw a line of best fit through there, it would look like that and like that. Okay, so that would be strong because a line represents the points very well. Strong negative correlation. Correlation is how they relate to each other. So correlation, and that's because it's the slope of that red line is going in a negative direction. So that's where the negative part comes from. Okay, so strong negative, strong positive. You can also have a, let's go like this underneath here. You could also have something that would look more like this. Okay, this is what we would call, okay, those points, they're no longer nice and tight knit like this. This is what we would call, there is, you could say, yeah, a line kind of like generally, all the points are generally going up that direction, but they're kind of more scattered throughout. This is what we would call a weak positive correlation, okay? Weak positive correlation. Because the points are kind of scattered out. Again, they are trending in a positive direction in terms of like a positive slope. If you were to guess where the next point's going to be, it's going to be somewhere up here. It's not going to probably be down here. That would be our guess. It's not going to be way over here. We know it's kind of trending, like if I were to graph the next point out here, it's probably going to end up somewhere over there. Right on the line? No, it's going to be scattered around. Over here, we would guess it's going to be right in here, nice and tight, right around the line. So this would be a weak positive correlation. The same then would be true of a weak negative if we drew the same concept like this, all going down that way, is that the going in this direction, it's a negative slope going that way. So that would be a weak, it's not nice and tight, negative correlation. okay? Weak negative correlation. So those are 4 options. There's a 5th option, so strong positive, strong negative, weak positive, weak negative. The 5th option, which is actually what I just drew here, okay, and we'll draw some other points. But if you have points like this, okay, so you have all these points, okay, you would look and say, if I were to draw another point like out here, because, you know, moving left to right, and I'm going to draw another point out here, would we say, oh yeah, the next point's going to be going like up, ascending in that direction, it's going to be up there? Well, it could be up, like I'll do it in green. The next guess, it could be there, right? But it could also end up falling. Your next guess could fall over here, or it could fall over here. Based off of the picture, we don't know where the next guess is going to approximately be. Versus like here, your next guess, you're not going to guess that a point's going to be down there because the data isn't trending that way. You would guess it's going to be somewhere up there. Here, it's definitely not going to be down here. You would have it somewhere nice and tight up there. So here, though, it's unknown what it's going to be. Here, 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 it's unknown. So in this case, there is no correlation, okay? So we would say little or no correlation on something like this. Little, the book says little or no correlation. Because I guess that you could argue there's some possible correlation, so that's why they say little, depending on what the data is, or no correlation on that. So that's just looking at the picture of the data to understand what the correlation might be. And the correlation has to do with how close-knit it is. Okay, so on that we've identified strong negative correlation, we've identified weak correlation, strong positive, strong negative, okay. So let's take a look at some data and what this is going to look like and what we're going to do with the data. So I'm going to erase, let's erase this. We're going to erase trend line, line of best fit, and we'll see where we might apply that terminology to some of the information given to us. Okay, so we are going to use, we'll call this number 1. We are going to use this data given to us. So they give us data. Now they don't tell us what the data comes from. They are just going to give you some XY points. So they give you a little chart here. Okay, so I'll give you a second to get the chart set up. And then, so we're going to use this chart to answer some of the questions. So this is 1, and then 27.5, and then 4, 35, and 7, and 42.5, and 10, 50, and 13, 57.5. Okay. So you have this data given to you. Okay. Now it says make a scatter plot. So number 1 here, we'll call this, using this data, we'll call this number 1 here. Make a scatter plot using this data. Okay. What does a scatter plot mean? Well, a scatter plot means you're just graphing the points. Okay. So when we go to graph the points, these are our points given to us, x, y, x, y, x, y, so on and so forth. A scatter plot simply means to graph the points. Similar to what we were doing over here, except we didn't know what the x, y points were, I was just making dots, but this would be considered like a scatter plot. So when you're going to make a scatter plot, in this case, one of the things is we're going 1, 4, 7, 10, 13. Making 13 slashes, pretty easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 there, right? 1, and then we're going to have 4, 5, 6, 7 goes there. And we're going to have, next one's 10. 10 goes there, and 13. Okay, so you could label that. So do 13 tallies and then make 1 through 13. I just was using the numbers they gave. To do the 27.5, 35, we don't really want to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to run out of room if we do that, okay? So one of the things you can do, and I've shown this, or at least working with some people at some point, is you could do some sort of, they make it look like this, and it doesn't really matter how many, maybe you just have like one like that. What that represents is that there is some sort of, I guess we could do that, some sort of gap here with a bunch of numbers that we're just not going to list. And then we could start our first number set here. Now, in this case, they're going 27.5 to 57.5, so that's a gap of 30. Again, we don't really want to do 27, 28, 29, 30, 31, 32, 33, 34, 35, all the way up to 57. That's going to just be way too much. So one of the things you could do is you could say, well, if I call this 25 and then I call this 30 and then 35, go in terms of fives, 45, 50, and then 55, and then 60 is going to get us all the way where we need to go. So this one can be in terms of ones, this one can be in terms of fives. To say, hey, there's a bunch of numbers, 0 through 25 here, but I'm not going to list 5, 10, 15, 20, 25, because none of those are going to matter for what we're doing. You can just do a little bracket, not a bracket, but like it's not squiggly because it's lines, but some sort of broken line, if you will, there, showing that all those numbers happen, and then I start at 25. So a scatter plot is simply doing this, over 1 up 27.5. It's just an estimation, over 4 up 35, right? Over 4 up 35. And then 7 is 42.5. Oops, wow, that was a mistake there. 35, I skipped 40. So over at 7 up 42.5. So just doing, man, I'm getting off here. That's because I messed up the 40. Sorry about that, I may erase that. So 30, 40, 45, 50, 55, 60. Let's see if I can do a little better there. So 42.5 over there, up 7, somewhere about there. And then 10, 50, over 10, up 50, so somewhere out here. 13 is 57.5, somewhere over here. Okay. So a scatter plot doesn't have to be extremely detailed. You don't need graph paper. You're just doing a sketch of the points. So this would be considered a scatter plot. So make a scatter plot with the data, done. I've graphed my 5 points, okay, for that. Okay, number 2 says, for this, says draw, okay, and determine the equation of a trend line that models the data. Okay, so when we do this, it says draw and determine the equation of a trend line. All a trend line means, okay, if you go back to the definition of a trend line, the definition of the trend line is, I'll go back to it for us, it just says a line that estimates the relationship between the data sets. Okay, so a trend line is just choosing 2 points on the line. Now I'll do it in a different color. So we have a bunch of points, and where do the colors go? I've lost my colors. Here we go. We'll just go with the purple one. A trend line would simply look like this. Okay, I'm going to take and I'm just going to connect the dots like this. Now in this case, my dots don't line up because it's just a line, it's just a scatter plot. If I look at this though, I would recognize that all of these actually should end up on the same line because it's a gap of 3, a gap of 7.5, a gap of 3, 7.5, so on and so forth. So actually all of these should end up on the line because they're all the same slope for that, but my scatter plot's a little bit off. So here I've drawn my trend line, done. So it says draw, and now it says determine the equation of the line that models the data. Okay, to find the equation of the line, we've talked about it. You need a point and you need a second thing. That second thing is a slope. So you need a point and a slope. Okay, they did not give you the slope. Okay, now we were kind of looking at, I was looking at over here, we could kind of navigate and figure out a slope from that. But what they did give you is a bunch of points. And so what you can do, remember, is you can find the slope, okay, of the line here, or between 2 points, and then you can, they gave you an unlimited amount of points that we can use. So the slope, to find the slope, you pick any 2 points. It doesn't matter because it's a trend line. I might pick the ones without the decimal to make my life a little bit easier initially. So I might pick these 2 points, and it's y2 minus y1, so it's going to be 50 minus 35 over 10 minus 4, so which is 6. So you would end up with 15 over 6, and then you reduce that. So 3 goes into 15, 5, and into 6 twice. And so now you know you have a slope of 5, 2, and then you are going to pick either point to use of the 2 that we just used for the slope, and then solve and write an equation. So I'm going to use 1050 as my point, and I would say y minus 50 is equal to m, and this is stuff we've been working on for quite a while, x minus 10. This is in point slope form. You don't have to use point slope form. And then I would say y minus 50 equals 5 halves x minus, okay, 25, because 5 halves times 10 is 2 goes into 10 5 times. 5 times 5 is 25. We're going to add the 50 over. So y equals 5 halves x plus 25. Okay, and that would be your equation of the trend line. Okay, again, you can pick any points you want. I just picked these 2, and then you found the slope, and then you write the equation of the line. So that's the trend line for that. Let me erase this. Then, so that models the data, done, we've taken care of that. The next question on there would be, it says, use the equation to estimate the value of y when x equals 3.5. So we want to use the equation to estimate the value of y when x equals 3.5. So here's your equation, okay? And the question is, when x is 3.5, what is y? So you're simply going to go y is equal to 5 halves x plus 25, and you're going to plug in 3.5. I might take 3.5 and turn it into a fraction, or you could take 5 halves and turn it into a decimal, and so you're multiplying 2.5 times 3.5 is fine to do, plus the 25. And so then you would do a little bit of longhand math. Remember, no calculators on the test. So 5, 25, 10, 12, 0, 15, and 7, and you get 5, 7, 8, 2 decimals, 8.75. So y is equal to 8.75 plus 25. And so y is equal to 33.75. Now, Does that make sense? Did you get 33.75? And the answer is yes, it does, because if you're plugging in 3.5 somewhere, it's going to fall into here. 33.75 is between these two numbers, so that works. Okay, so this is enough to get you started, and then you can also work on those mid-chapter assessment corrections and then get started on 5, 6. We will carry on with more of a lecture tomorrow.